So what we have here is a three-dimensional trig problem, and the way to visualize it is if you visualize the triangle ABC being flat on your desk, and then the line TB goes straight up at 90 degrees off the desk. So ABC is the plane of your desk and BT is just turning straight up, and M here, the midpoint of AC, connects up to T. So in a way we actually have a right angled triangle here, which I'm just going to draw on with BT and M. So that can come in the line here, and that makes a right angled triangle like so. By putting that line in, because M is the midpoint of AC, and the fact that ABC is isosceles, it says so in the question, plus you actually have the same lengths here, AB equals BC. That means that this bisects at 90 degrees, so that is also a right angled triangle. So we have a second right angled triangle here. Now we want to find the angle between MT and the horizontal plane, so that is the angle that is just here in blue there. Now typical for an exam question, if we have multiple triangles, here we started off with two, if our answer is going to be in this triangle here, then we have to begin our workings with this triangle here. So we're going to look at the one on the plane here, ABC. We've already cut it into BCM, and that's the one we're actually going to work with first. I know by looking at it just by inspection that this angle here is 20 degrees. And the reason it's 20 degrees is that I have an isosceles triangle, and the other angle is 40 degrees. So 2 20s is 40, plus 140 is 180. So I'm going to work with that. I've got my length of 8, and I'm going to try and calculate this length here, which is MB. Now, if I redraw that triangle, just so you've got a bit of a clearer idea, and I think it kind of helps to redraw some of these triangles when you're working on these problems, especially just to get your head around which is the hypotenuse, which is the opposite, which is the adjacent, and so on. So that's 20 degrees. I've got 8 centimeters, and I want MB there. So this is the length I'm trying to find here. So using trigonometry then, I'm going to be dealing with the opposite, which is here, and the hypotenuse, which is going to be sine. So I'm going to write that sine of 20 degrees is equal to the opposite, which is MB, divided by the hypotenuse, which is 8. Rearranging that, clearly MB is equal to 8 sine 20, and MB therefore works out to be something like 2.736. The question asks for answers to be to 1 decimal place. Your workings really should go to 2 more than that, so go to 3 decimal places at least, or use the memory function on your calculator. So now I know the length of MB. I'm going to write it on here, 2.736, and I can now switch to my second triangle. My second triangle is this one here, MBT. I know the length here, it's 2.736. I know the height here of 10, and I want to find this angle. So I'm just going to redraw it, and I'll put it on here. So this is B, this is T, and this is M. It's 90 degrees. I know that BT is 10 centimeters, and I know I've just worked out that MB is 2.736. This is the angle I'm looking for, so I'll call that X. And here I've got a trig question where I'm going to be using the 10, which is opposite my angle, and the 2.736, which is adjacent to my triangle. So opposite and adjacent is tan. So I'm going to write down that the tan of X is equal to the opposite, which is 10, divided by the adjacent, which is 2.736, which I've left in my calculator, so I'm going to get a very precise answer here. So X is equal to the tan to the minus 1, or if you prefer the arctan of 10 over 2.736. Make sure that is inside a bracket, and when you put that into your calculator, you will get the answer of 74.7 degrees to 1 decimal place, and we are done.